Okay, cycle 2, week 5 science. We have 2 experiments again for this week, and they are on pages 8 and 9 of the Van Cleve Science book. They're experiments number 13 and 16. So number 13, the first one, is called expanding. And this one, each of the kids, this is the one where you draw dots on a balloon and then you blow it up and you watch what happens to the dots as the balloon expands. So the kids will be paired up to do this together, but they'll each have their own balloon. So the first thing that you're going to have them do is blow up the balloon to about an apple size. You want some tension so that it's easy to draw the dots. Alternatively, you could just draw the dots on it while it's flat. That seems to be harder, especially for the younger kids. So you can kind of decide, or maybe play with it at home and decide what you prefer or what you think would be easier for your kiddos. But for this video, I'm going to just blow it up a little bit. So just a little bit, just to get some tension on it. And then you'll take a permanent marker and you'll draw, several dots. And they don't have to be any size. And you really don't have to do it over the whole thing. The kids will probably want to, but really just what you can see. So I can do a few more. This actually looks a little like a strawberry. Okay, so I have some dots on my balloon. And the reason that you want to do this in pairs is so that the kids can watch each other. So as their partner blows up the balloon, they can watch what happens to their partner's balloon and vice versa. And you want them to be observing and then asking what is happening and how consistently is it happening and that kind of thing. So now we're going to blow it up. And see what happens to my dots. They move together. None of the dots move closer together. They all move further apart, but some of them moved further apart than others. So the ones that were closer to the top of my balloon didn't move as far away, didn't move further away from the dots next to them as much as the ones that were down on the bottom end of the balloon. So again, you want to really harp on them observing and making those observations and asking themselves maybe, why is that happening? Sorry, I'm letting the air out of my balloon. The why explanation in the Van Cleve book says that astronomers believe that galaxies are moving away from each other similarly the way the dots on the balloon move. And not all the galaxies are moving away from us at the same rate. And then they go on to talk about how Dr. Hubble discovered that the further away a galaxy is, the faster it seems to be moving away from us, which also is illustrated by blowing up the balloon. Those two things might be a little bit tougher to explain for the younger kiddos, but might be good little seeds to plant in the minds of some of those older kids. And then it also says that since no two galaxies seem to be getting closer as they move, scientists believe that the the universe is expanding, which is very interesting. The Indescribable book also has something on the size of the universe. It is page 148 if you have it, devotion number 71, just the right size. And it actually talks about Dr. Hubble in here as well. So even if you just used it to talk about Dr. Hubble, it might be good to add in. The second experiment for this week is a little crazy. I will have enough supplies at the table for everyone to do this in pairs, have their kids do this in pairs. But I really think for the younger classes, and we've got a lot of young kids. So this might be a good one for maybe if you have one or two moms, each of the moms can do it and you can have a smaller group of kids watching as the mom does this experiment. But this is going to be one that's going to be not only kind of tricky for the kids to do with their fingers, but a little bit more dangerous for them to do on their own. So I'm going to illustrate it for you. This is number 16 on page 9, and it's called In and Out. And the purpose is to demonstrate forces that keep satellites in orbit. So the materials that you will need are a roll of masking tape, and a yard of string. You need a spool, a wooden spool, and a metal spoon. And what you're going to do is you're going to tie again, this will be one that the first classes that go will probably have this already set up if you want to go ahead and use one that's pre-done. But like I said, I'll have enough for the kids to do them in pairs. So you want to tie the string, one end of the string around the masking tape, and then you want to thread it through the spool and then tie the other end around the metal spoon. And then what you're going to do is you're going to hang on to the tape with one hand and the spool with the other hand, and then you're going to get the spoon spinning. And then once you kind of get it spinning, you're going to let it go and watch. Sorry if I can do this. You're going to let it go and watch the movement of the tape. Now, I'm not doing mine really fast because I'm not standing up, but I also don't want to hit myself in the head with the spoon. But you can see why maybe it might not be a good one for the littlest kids to do it. But the idea here is that the spoon is spinning in a circular path with just the weight of the tape that is holding it on the string. And the idea is introducing centripetal force, which is that a moving object has force that is directed towards its center. And that is what's keeping it in a circular path. So it applies this to moons that orbit planets, planets that orbit the sun. They're all pulled towards the body that they orbit around. I don't know if you could really see in this video. In a second, I'll stand up and I'll show it to you. But if you get it going, then the tape starts to move up. And so you can see that without something pulling on the tape is going to be drawn closer and closer to the spoon just because of the force of the motion that is spinning. But if there is gravity that is being exerted on the spoon, then it will stay in its orbit and it won't move closer to or farther away from the body that it's orbiting. So, a couple of application questions or thinking questions. This first one would be really great for any of the kids, no matter how old they are. But how did we get our spoon started? What was it that set the spoon spinning? And you can just link that to the fact that the planets and the moons that are in orbit had to start in orbit in order to be able to continue in their orbit. So again, it speaks to the intelligent design of our Creator. Another question might be, what explanations do we have for how moons and planets started in their orbits? This might be a better one for the older kids who have been exposed to some other ideas besides the creation science that we teach at home and in CC. But what is it that other people say? And are there questions that we can ask that might make someone who doesn't believe in an intelligent creator think about how it was possible for these things to get started? So both of those are good application questions. And, obviously anything that we can do that speaks to what our Creator has done and how big our universe is speaks to who God is and how big He is. And then we can always bring that back to how much we can trust Him. So that is cycle 2, week 5.